my friends, and welcome back to another lesson in Algebra 1. Today's lesson is Unit 4, Lesson 3. We're going to be looking at some real-world examples of slope. Remember, this is one of your equations here, m equals y2 minus y1 divided by x2 minus x1. We will encounter some units here in these problems, and units help to provide explanation for what's happening, in what we see. Okay, so the objectives for today are I can interpret a graph or a data table or a word problem to find slope. So what would be the slope in those three types of representations? And then I know real world problems have units, and the units, I can deduce those, the proper units to use, and I know that they convey information. Those units are valuable pieces of information. All right, so let's go start writing some notes. So slope, it is also known as the rate of change. And so we can have units associated with that. So for example, miles per hour, we talk about that all the time. Like if you're driving 35 miles per hour down the road, that is a rate of change. And those would be units attached to that. Another one that we use all the time is the cost per unit. And you may not use those words, cost per unit, exactly, but we could say something like, say, meat is $5 a pound. Okay, that would be an example of a cost per unit, which would be rate of change, or also known as slope. Okay, so wait, how are we going to solve these problems? Well, the first thing that we're going to do is we're going to break out our good friend, the slope formula. So we're going to be writing that over and over and over again today. Why do we write it down for every problem? Well, it helps to stick it in your head. That's why. Okay, we're going to decide what would be the independent variable. And the independent variable is the x component. Okay, and we're going to decide what is the dependent variable. And this would be the y component. It may help to make a table. Let's see, we're going to decide on proper units. And so one of the important considerations here, and the reason why we want to know what is the dependent or independent, is the dependent or the y variable will be on, this is going to be a word here, we'll fill this in, this is going to be on top. Okay, and then the independent or the x variable will be on the bottom. We could go and just add some colors there. Let's see, the bottom of the ratio. Okay, so why is that? Well, look up here. This is, my x's, they're on the bottom, and my y's, they're on the top. Okay. Alrighty, so let's go ahead and write down the thing that's over here in this blank. We're going to have y units on top over an x unit. This is supposed to be a fraction bar here. It looks a little confusing, but we got a y unit over an x unit. An example of that would be miles per hour. Sorry, the doorbell rang, and now my dog is losing her marbles. Alrighty, my friends, let's go ahead and look at an example here of what is going on. So we have a storage tank that is slowly draining, and the table shows the relationship between time and hours and the amount of water remaining. Well, we know that we're going to be finding slope, okay? So we know that for sure, that we are going to find slope. And that equation up here, we have right here, m equals y2 minus y1 divided by x2 minus x1. I'm just going to write that over again. Okay, so we got y2 minus y1 divided by x2 minus x1. We're going to label everything. Okay, now this is my x here. My time is x, and my water is y. Okay, this is an x value, right? And this is a y value. This is the first pair we came to, so I'm just going to label those ones. This is an x value, and this is a y value. It's the second ones we came to, so I'm just going to call those 2. That's it. That's the whole mystery of how those numbers, are assigned. Is just the first one I came to and the second one I came to. Okay, so we are going to take our y2, which is this guy here. It's 34. So 34 minus y1, which is this 46. And it's going to be divided by x2, which is 5. And then x1 is 2. Okay, so 34 minus 46 is going to give me negative 12. And 5 minus 2 is going to give me 3. So when we divide that out, negative 12 divided by 3 is going to give me negative 4. Well, we need to have units. The units are telling us something important, okay? So when we look at this right here, and we can see that we're going to put the y unit over the x unit, okay? And they gave you this example of like miles per hour. We're not doing miles per hour, but we can do gallons per hour, okay? Our y unit goes on top and our x unit goes on bottom. Alrighty, so we're going to write y unit on top and x unit on bottom. So let's do this. Okay, so we've got negative 4, and it's going to be gallons. That's my y unit per hour. Okay, so we could write it as a fraction. We could have also written it out in words. So we could have written it like, it is draining at negative 4 gallons per hour. Okay, so we could have written it, in words too. That's a slope, okay? That's what the real world slope is here in this case. Alrighty, let's look at example 2. So example 2, we have the situation where it's a winter morning and the temperature was 41 degrees at 5 a.m. And the temperature dropped. So we know dropped, it means it went down. And by 11 a.m., it was 23 degrees Fahrenheit. What is the rate of change in the degrees per hour that the temperature dropped? You know what I'm going to do? I think I'm just going to go ahead and make myself a data table so that I can just write everything down. So, my x, this is going to be time, and times in hours. Okay. And then the temperature is going to be my y. So this is my y value. My temperature is going to be in degrees Fahrenheit. Let's put our data points in here. At 5 a.m., it was 41 degrees Fahrenheit. At 11 a.m., it was 23 degrees Fahrenheit. Okay, why did I end up putting temperature in the y and time in the x? That is because the temperature is dependent on the time, okay? So depending on what time we took that temperature, that determines what the temperature is. So this was my independent variable, and this was my dependent variable. And frequently, when you just see time, it's going to go on the x. Like that's just kind of a general rule of thumb that you can use. All right, let's label these. So this is an x value. This is a y value. This is an x value. This is a y value. This one here is the first x I came to. This is the first y I came to. This is the second x I came to. This is the second y. So when we do our slope equation, I'm going to write my equation down again. Remember, my equation's from up here, like, so I'm not just, grabbing it out of thin air. It is up here. So I'm simply writing that over again. And writing it over again is good for you because it helps to get it into your brain. It helps you to pay attention and kind of focus on the problem. And it helps you to not to realize that things just aren't random. Like, these numbers come from somewhere, right? These formulas come from somewhere. All right, so let's see. We're going to go ahead and plug this in. So let me grab this. We've got y2 is right here. That's my 23. So I'm going to write 23 minus my y1 is next. So that's 41 divided by my x2, and that's 11. And then we've got x1, which is 5. Okay. So let's do a little bit of math here. 23 minus 41. That is going to be 18, negative 18. And then 11 minus 5, that is going to be 6. And so we can simplify this. Negative 18 divided by 6 is going to give me negative 3. But we also need some units, okay? And it actually told us this. It told us right here, degrees per hour, okay? So the temperature is dropping negative 3 degrees. Oh, I don't want to write that. Let me go ahead and put the symbol. I'm going to do degrees Fahrenheit per hour. Or you could have written it like, say, it's dropping negative 3 degrees Fahrenheit per hour. Okay. Either one of these is an equivalent, we could write that. Alrighty, so this is why units also tell us something important here, because if I just wrote negative 3, it could be negative 3 what? What are we even talking about? Oh, we're talking about degrees Fahrenheit per hour. Okay, the units tell us something information, or tell us important information. I do want to point out something here real fast. We had this where it was slowly draining. That implies this negative slope. Okay, it's draining, it's going down. This one, we see that, the temperature is dropping. A dropping temperature implies a negative slope. Okay, so those are giving you some context clues of what sign your slope might be. All right, let's look at this. We're going to do reading the slope from a graph, which is easier. We like that. Okay, so let's see. I'll go and grab this. I'm just going to pick a point where it crosses a hash mark. So it's crossing right here, and I can see it's crossing right here. I can go up and over. I do want to point out that this is going to be a negative slope because it's slanted to the left. That's different than this here where it's pointing to the right and it's got a positive slope. Okay, so this has a negative slope. So let's see, we're going to do slope is rise over run. Okay, let's look at this, but I do also need to pay attention to my values here. It's gone up 2 hops, but look, it went from 5 to 15. So when it went up 2 hops, this value is actually 10. Okay. And then it went, so my rise was 10. And then my run is 2 hops. But check it out. My 2 hops is going from 4 to 2. So those 2 hops is just 2, okay? Because it went from 4 to 2. So the difference between those is 2. This is going to be negative because we can tell which way it's slanted. So this is going to give us negative 5. Well, what are my units? It's negative 5. Negative 5 what? It's going to be negative 5. Let's go up here and remind ourselves what thing we put on top and what thing we put on bottom. Okay, my y unit goes on top and my x unit goes on bottom. Okay, so y on top, x on bottom. So my y unit, we've got ounces per minute. So it is ounces per minute. Okay. Let's go back and read what this problem is saying. The graph shows the volume in ounces of an iced tea cup based on the number of minutes Emma has been drinking. What is the rate of change and what does it represent? Okay, so the rate of my change means that Emma is drinking 5 ounces per minute of her iced tea. Okay, so our slope is this. And the drinking, this part implies removal. It implies going down. It implies that negative slope. So this word, you're drinking 5 ounces per minute. All right, let's look at this next one. So we've got this guy. We're going to go, I'm just going to pick a point. I'm going to pick here. That looks as good a point as any. I'm picking where it's crossing the hash mark. Notice I'm not picking here because that would be more difficult to interpret. I mean, it's between 12 and 14 and you're like, oh, it's probably, 12 and 16 and it's probably 14. You're probably right, but it would be much easier to pick this as my point, right? Because it crosses that hash mark exactly. So I'm just going to go ahead and erase this one because yeah. All right. So let's look at this. This is going to be a positive slope. We already wrote that down up here. So life is good. We want to remind ourselves that slope is rise over run. Now, when we are looking at these graphs, just because we see that it is going up 2 hops, that doesn't mean that we put a 2 over here. Okay. Why? Because look, we're going from 8 to 16. The value of those 2 hops is actually 8. Okay. We had to read the labels, right? The 2 hops was actually a value of 8. We're going to go over here and we're going to do 1, 2, 3, 4. We read down here and we can see the value of the hops is, it's going from 1 to 4, or I'm sorry, let's do 0. From 0 to 4. So, that is 4. Okay. So that 4 hops actually was the number 4 versus the Y, those 2 hops meant 8. All right. So 8 divided by 4 is going to give me 2. But we need to know what is it? 2 what? Okay. We solved this, but 2 what? What does that even mean? Okay, so let me get my highlighter here. So the graph shows the height in inches of Bowen's sunflower based on the number of weeks it was since it was planted. What is the rate of change? Okay, we figured out it's this positive 2, but what does it represent? Okay, so what this is telling us is that Bowen's sunflower, okay, is growing. It's growing 2, but 2 what? It's growing 2 inches per week. Okay, 2 inches per week. So we're getting those units straight off of our graph. Alrighty, my friends, that's the end of the notes for today. Until next time, bye.